Hello guys, welcome to Maths with RN, a class on logarithms for numericals and inequalities. In the previous discussion, we had seen the logarithmic graphs. Let us say we take a y equal to log x base 2 function, and if you would take the graph of this function, it would simply be an increasing function with cutting x-axis at x equal to 1, this being the plot. And now, suppose you are asked a question that log x base 2 greater than 3 has what solutions? I mean to say, find solutions for this inequality. A basic question though, but can be solved using graph very easily. See this. Let's say this is the level of 3, y equal to 3, or log x base 2 equal to plus 3 at this level occurs. That means there is a corresponding position of x on the x-axis at this point where the x value shall be equal to 2 power 3. That means 8. At x equal to 8, you will get log x base 2 equal to 3. You are asked log x base 2 to be greater than 3. That means your requirement is for the log values greater than 3. That means corresponding on the log graph, you can proceed to the right side, upwards. And that means the corresponding values of x would be this side. And that means any x greater than 8 would be your solution. This is the solution set for the inequality that has been asked. Now, how do we reach this? On a simple basis is like this. When the function has a base greater than 1, when the base is greater than 1, if, then what happens is, as x increases, the log values also increase. You observe for any two set of points, as x increases, the log value also increases. That means, if you want log value to be greater than 3, then if I convert this inequality directly to an exponential form like this, x compared with 2 power 3, inequality remains same. If this happens, then this is going to happen. And you can see this on the graph. You can see it here. X greater than 2 power 3. That means your inequality remains same if base is greater than 1. This is the clue. This is the secret for solving inequalities. This is an example where the base is 2, base is greater than 1. The function is increasing. As x increases, function rises, log value rises, and hence inequality stays the same. Let's take one more example. And in that case, we will consider the base to be a fraction between 0 and 1. Say, for example, you are asked y is equal to log x base half. This is, let's say, a base of half. And for this function, the graph, as you know, would be a decreasing function, cutting x-axis at x equal to 1. And now, suppose you are asked that log x base half is supposed to be less than 3, then what will be the solution set? Find the solutions for this inequality. Now again, we go by the same approach. The approach is, let's track the level of 3. Let's say plus 3 is the value of log x base half. At this level, you are at a certain corresponding point on the x-axis, and that position is x equal to how much? X equal to how much would be obtainable from the equivalent exponential equation. Half power 3. half power 3. That means 1 by 8. This is 1 by 8 as a position where log value is equal to exactly 3. You require log values to be less than 3. Now that means your navigation on the plot goes this way. You require less than 3. That means from this point you are going to go downwards, downwards, you are going to go downwards, and that means the solution set would lie to the right of x, and hence x would be greater than 1 by 8. This is the solution set. Now dear, how do we come to this solution? Directly. The direct method would be like this. Convert this logarithmic inequality to an exponential one. Catch this x, keep the other things in the exponent form, half power 3, half power 3. Now dear, since the base is a fraction, since the base is between 0 to 1, then as x is increasing, log value is decreasing. As x is increasing, log value is decreasing. That means inequality will reverse. That's the clue. And this is the solution set. You see this? The same solution set. X greater than 1 by 8, x greater than 1 by 8. That means the basic law is if base is a fraction, then inequality reverses. This is the clue. Look at this situation. This is how we solve logarithmic inequalities from a consideration of base. Look at the base first. Look at the base of the log. Then you take care of the inequality. If base is a fraction, inequality will reverse. If base is greater than 1, as you saw earlier, inequality will stay the same. Now, let's go to some serious questions. Some basic serious questions. Say, for example, I am given two numbers and I want to compare them. How do I compare? Say, for example, I am given A is equal to, let's say I am given A is equal to 2 and I am given B is equal to 1 by log pi base 3 plus 1 by log pi base 4. And I'm asked a question as to which one is greater or smaller. Find the greater. That is the question. Find the greater. If that is the question. How do we go? This is a simple constant. You can do nothing about it. We can resolve this. And how do we resolve this? Now say this. If I consider log A base B. Log A base B can be resolved as log A base K by log B base K. Therefore, this can be written as 1 by log B base K by log A base K. And therefore, this can be written as 1 by log B base A. Now look at this. You have a new transformation. Log A base B is equal to 1 by log B base A. This is a new transformation, can be applied here, and therefore the value of B in this case would become, this one would become log 3 base pi, and the other one would become log 4 base pi, and therefore this altogether becomes log 12 base pi. 3 into 4, 12. Log A plus log B equal to log AB, the product rule. Log 12 base pi. Pi is equal to 3.14, roughly. Squared, pi square won't be greater than 10. And you require 12. This value is definitely greater than 2 because pi square is less than 12. Sis. Pi power 2, pi square will be less than 12. That means your question is solved. Who is greater? B is greater. This B is definitely greater than A. Let's go to one more. of base root 2 into x minus 1 greater than x plus 5. Suppose you are asked, find the set of real values of x. Find set of real values of x that satisfy this inequality. Here is how we go about it. Suppose I am in an exam hall. This is how I would go about it. Very simple thing, man. Here appears a 2. That means if I write log of x minus 1, 2 power half. You remember 2 power k would bring a 1 by k. 1 by k means 1 by half. 1 by half into log of x minus 1 base 2. And that means this would make 2 times log of x minus 1 base 2. This thing which is at the power becomes this thing. Or in the best case this. And if this thing becomes this, let's rewrite the left hand side. The left hand side becomes equal to 2 power log base 2 into x minus 1 whole power 2. What would you say this is equal to? By definition of log, this is equal to exactly x minus 1 whole square. See this. That means if this left hand side is greater than the right hand side, I can solve this quite easily. X square minus 2x plus 1 greater than x plus 5. I hope I have gone a little more speedily in coming to this particular step. I have gone that deliberately. You should be able to apply properties this fast in an exam. Let's go ahead. X square minus 3x minus 4 greater than 0. There, minus 3x minus 4 greater than 0. Can we factorize this? I hope we can. X square minus 4x plus x minus 4 greater than 0. That means x into x minus 4 plus x minus 4 greater than 0. How do we solve this? How do we solve this? That makes x plus 1 into x minus 4 greater than 0. How do we solve this? Very simple. Now here is another way we can solve an inequality. On the number line, plot the roots. The roots of this is minus 1. The root of this is plus 4. And next what? If suppose you stand to the left of minus 1, if this is the position of x, then what is going to happen is this: x is less than minus 1. Then x plus 1 is going to be less than 0. Look very carefully. X is less than minus 1. Then x plus 1 is less than 0. This factor turns negative. X plus 1 is a negative value in this region. Similarly, the same x is less than 4. The same x is less than 4. That means x minus 4 as a factor is less than 0. That means x minus 4 is negative again. Now consider, if I am to the left of a number, my factor turns negative. Therefore, the product here turns negative into negative. It turns equal to positive. Now suppose you are in this region. Your x is now, the product here is positive effectively because of the product of two negatives. Now suppose your x is somewhere here. Now what will you do? Now suppose it is greater than minus 1. That means x plus 1 is greater than 0. This factor turns positive. But in this region, if you are still to the left of 4, that means this factor will turn negative. The product will be a negative. That means you are here negative. Again, if I move to the right of 4, I also move to the right of minus 1. Both factors will turn positive. If both factors turn positive, it would be like this. Let's say your x is now navigated to this position anywhere to the right of 4. Now, if your x is greater than 4, That means x minus 4 is greater than 0. That means x minus 4 turns positive. This is what I'm saying. And same happens with x equal to minus 1. Oh, sorry, x greater than minus 1. Both factors turn positive. The product turns positive. When the product turns positive, write it above the line. When the product turns negative, write it below the line. And also, this is a simple graphical representation of a quadratic product or a quadratic factor which would otherwise go like this. We will discuss about the quadratic graph in detail when we talk about the quadratics as a topic. As of now, if this is the case, then what do we need? Our need is basically this. This is what we need, and we need the product to be greater than 0. That means the solution lies to the left of minus 1 and to the right of 4. If that is the case, then let's say your solution, let me see, your solution lies absolutely to the right of 4 or to the left of minus 1. Now let's consider this solution. Let's consider this solution. You got a solution as x to be less than minus 1 or x to be greater than 4. Consider this. You have x minus 1 as a number on which log operates. If your x is less than minus 1, then this particular factor, x minus 1 as a factor, would turn negative. It would turn to minimum value of minus 2. It would be negative. Log doesn't operate on negative numbers. That means this solution cannot be taken. Only this solution can be taken, and that means your answer is simply x element 4 to infinity. I hope you understand intervals. If you don't, doesn't matter. I will explain that later, but for now I will write x is greater than 4 as a solution. X is greater than 4 as a solution. This is how it goes. Alright dear. Okay, stay focused on this. We take the next question now. The next question is a little lengthier than this. Suppose I have 1 plus log of x minus 1 base 2 less than equal to log 4 base of x minus 1. And we need to solve for the set of values of x. Minus 1 base 2 less than equal to log 4 base x minus 2. Now dear, how to solve this? We had seen that log a base b is equal to 1 by log b base a. This property can be used where? Here. Log of 4 base x minus 1 is equal to log of 2 square base x minus 1 is equal to 2 log 2 base x minus 1. Therefore, if I take log 2 base x minus 1 as a t, if I put log x minus 1 base 2, or let's say, okay fine, put this equal to t. That means this value is equal to 2 by t. Consider this. This is equal to 2 by t because this, if this is t, then this is 1 by t. Now, let's get back to this question. We have 1 plus log of x minus 1 base 2, which is a t, less than equal to log 4 base x minus 1, which is equal to 2 by t. This is how it simplifies in terms of t. Now dear, let's cross t to the other side. t square less than equal to 2. That means t square plus t minus 2 less than equal to 0. Let's simplify this as a factor. Plus 2t minus 2 less than equal to 0. T into t plus 2 minus of t plus 2 less than equal to 0. T minus 1 into t plus 2 less than equal to 0. This inequality has a solution. Just as I told you, on the number line of t, locate the root of this factor, that's minus 2, and the root of this factor as a plus 1. And now dear, to the left of minus 2, both factors turn negative, product turns positive. Between minus 2 and plus 1, let's say this factor, I mean t with respect to 1. T is less than 1 here in this region. T is less than 1. So this factor is negative, but t plus 2 means t compared to minus 2. T greater than minus 2. T greater than minus 2 in this region. That means t plus 2 greater than 0. T plus 2 is positive and overall product would be a negative. To the right of 1, any position would produce both factors positive and therefore product is positive. In this case, it's like a quadratic of t with two factors having one root each and going like this, opening upwards. As I said, we will discuss quadratics even later. Solution, however, turns out for less than equal to 0. This product less than equal to 0. That means less than 0 and equal to 0 at these points. That means I have a solution set from minus 2 to plus 1, both inclusive, So I can say t has a solution set from minus 2 on to, let's say, plus 1, both inclusive. This is values of t. Let's take the values of t from here and replace for the inequality, and we will get something like this. Minus 2 less than equal to log of x minus 1 base 2. Log of x minus 1 base 2 is the value of t. This is one part of the inequality, and another part means along with this I'll have to solve another, and I will have to solve log of x minus 1 base of 2 less than equal to 1. And means intersection. I will take an intersection of the solutions obtained from these two inequalities, and let's solve this. 2 power minus 2. 2 power minus 2 equal to x minus 1. This is straight 1/4 greater than equal to x minus 1. X greater than equal to 1 plus 1 by 4. That is 5 by 4. This is one part of the inequality. Let's take another. X minus 1 less than equal to 2 power 1 means 2. That means x less than equal to 3. This is another part of the inequality, and they have a ANDing. They have a ANDing. If they have an ANDing, then the solution set from here and from here come on a number line with a 5 by 4 and a 3, both inclusive. I have the solution set lying from here till here, and then I can say that x is element of 5 by 4 closed onto 3, and that's all? No, not that's all. Let's look at the equation back again. I have an x minus 1 here, I have an x minus 1 here, and which is acting as a base, and which is acting as a number on which log operates, and that means there is a trouble. The base of log, I said base of log cannot be 0, cannot be 1, and cannot be negative. Negative means we are talking about x minus 1. Negative means we are talking about x less than 1. Is that a challenge here? X less than 1, is that a challenge? No way. 5 by 4 is more than 1. Plus 1 lies somewhere here. So this is fine. This is obeyed. My base is not negative. If base would have been negative, I said this would be negative, then x would be less than 1. We are to the right of 1. So not a problem. Then x minus 1 cannot be 0. That means x cannot be 1. Oh yes, that is also obeyed. X is not equal to 1. That is also accepted. What about this, dear? X minus 1 cannot be 1. That means x cannot be 2. Now here is the problem. I have a 2 somewhere here. 2. That means this 2 as a number has to be eliminated completely. Hence, the solution set finally can be said to be this. This is the answer to this question. Final answer. Thank you. See you in part 3. Have a great day.